Long time no see. My name is Sean, and this is my fifth video assignment of Fundamental of Semiconductor Device 2. So for today's video, we're gonna talk about some terms and how to sort some terms and definitions in some MOSFET devices. So we're gonna talk about those terms. But we already talked about some accumulation and flat band and depletion in inversion resume for the last video. So for now, we're gonna talk about some NMOS and PMOS stuffs and some operation modes of MOSFET and the IV characteristics about MOSFET. So for the first, we're gonna talk about some N-type, P-type stuff, and some resumes, really short. For the first, N-type and P-type. So N-type semiconductor means the semiconductor's majority carrier. If the semiconductor's majority carrier is electron, it means it's an N-type semiconductor. And if the majority carrier is a P, which means hole, it means it's a P-type semiconductor. And some resumes in the MOSCAP or MOSFET. I have graphs. I mean the energy band diagrams. So we can talk about some resumes with these figures. So for the first, we're going to talk about a accumulation resume. And yeah, so we're going to talk about it in the P-type. Whatever, P-type or N-type, whatever. So when it's a P-type semiconductor, as you can see, if we put some minus bias in here, minus bias at the metal, then it's a p-type semiconductor, so majority carrier will be a hole. So the hole attracts by the minus bias, so it will be accumulate in channel. The hole will accumulate in channel. And for the N-type, we're gonna add some plus bias at the metal. Then the majority carrier, which is electron of N-type semiconductor, will accumulate to the channel. So this will be accumulation resume. And for the next, it's the flat band resume. It means the metal's work function and the Fermi level of the semiconductor is constant, like this. So this means it looks like the band is flat, right? So we call this regimen as a flat band regimen. And this is a thermal equilibrium states. And for the next, we're gonna talk about we have um, depletion regimen and inversion regimen. So first, we're gonna talk about the depletion regimen. For the depletion regimen, it means if we add for the p-type, which is the p-type substrate is here, we're gonna add some plus bias for metal. And if we put plus bias in metal, then the hole which was accumulated in the channel before at the accumulation region will pushed away. Pushed away because of the plus bias, then it will be depleted and gets way more inside of the substrate. And that means, and for the p-type, the hole will be depleted. So this is called as depletion region. And for the n-type, there was the electron, which is the majority carrier of the n-type semiconductor, will depleted by the minus bias, which is added in the metal. So this regimen is called as a depletion regimen. And for the fourth, we're gonna talk about inversion regimen. So if we put more positive bias, more bigger positive bias at the p-type substrate, then the depletion will way bigger. Depletion will happen. It will occur way more. So there's there might so the the minority carrier of the p substrate, the electron's concentration is way more than the majority carrier's concentration, because the hole will deplete it way more than the depletion region, right? So in this part, the channel part will more negative than before, right? So we can't call it as a p-type anymore. So it means it it means the inversion happens in channel. So that's why we call this part as an inversion layer. So this regimen is called as the inversion regimen. And for the n-type, there was the electron, which is the majority carrier of the n-type substrate, but the depletion occurs, so the electrons will deplete it way more if we add higher negative bias at the metal. And if it happens, the minority carrier's concentration will be way higher than a majority carrier, the electrons carrier. So we can say the inversion occurs in the channel. So that means this is the inversion layer, and this figure says it's an inversion regimen of the n-type semiconductor. So that's a definition of those regimens in MOSFET or MOSFET. And for the next, we're gonna talk about a NMOS, PMOS, and MFET and PFET. It's easy because we can say NMOS is the MOSFET or MOSCAP um, the MOSFET which use the electron as a channel, and the PMOS will be the MOSFET that use the hole as a channel. So that's why we call the first one as an NMOS and the second one as a PMOS. So I have a figure of the structure of NMOS and PMOS. And this is the NMOS, also we can say is NFET, and this is a PMOS as a PFET. So for the NMOS, we use the we use the we use the heavily doped source and drain, which is heavily doped as electron. So we can say it's N plus, and a P plus at the source and drain. So we so the channel will be created between the source and drain, and the channel will use electron because the source and drain is heavily doped as electron. So that's why we used so electron will move through the channel, and that's why the NMOS used the electron as a channel. And in the PMOS, we use source and drain with a heavily doped source and drain, which is heavily doped with the P, in which is the hole. So the channel between the source and drain will use the hole as a channel, and that's why we call this a PMOS. And for the next, we're gonna talk about the linear region and the saturation region. So I have a figure of the MOSFET's IVG ID3D figure, IDVD characteristics. And that's, I can't find the figure. Yeah, it's here. As you can see, this is ID/VD characteristics of the MOSFET. And with these lines, we can see here, this part, this region have a linear relationships between the ID/VG, so it just increased with the increased linearly. But in this part, we can see the ID, the drain current is constant. So we can call this as a saturation region. And so we're gonna talk about the linear region, which is so when the gate bias, the difference between the gate bias and the threshold voltage is difference between the gate bias and the threshold voltage is bigger than a drain bias. The IDVG, IDVD characteristics will have a linear region like this. But when the difference between the gate and the threshold voltage is smaller than a drain voltage, it will have a saturation bias. So we can get an IDVD characteristics like this with the linear region and a saturation region. And for the last one, we're going to talk about the operation mode of MOSFET. We can separate, we can sort with a depletion mode and an enhancement mode. So there's a picture of the different operation mode, and I'm gonna talk about some transfer characteristics about those modes and some types of the semiconductor. So if it's the n-type semiconductor, and if the anti-semiconductor is the enhancement mode, so for the first, we're going to talk about how to separate, how to sort, how to definite the enhancement mode and a depletion mode. So the enhancement mode means if the gate bias is 0 and there's no channels in the MOSFET, we can call it as the enhancement mode. And if the gate bias is 0 but the channel is already created, and then we can call it as a depletion mode. So if it's a depletion mode, the channel is already created. So if we don't add the gate bias, if we don't add the bias at the gate, the current already flows because the channel is already created before, you know. So come back to the transfer characteristics. So if the n-type if the anti-semiconductor is enhancement mode, so as I said before, if the gate bias is 0, there's no channel in enhancement mode, so there's no current flows before the gate bias it will be a threshold voltage. And when the gate bias is equal to the threshold voltage, the current will flows. I mean, the channel will create it. So the transfer characteristics will draw like this. But for the depletion mode in n-type semiconductor, even if it's not, even if the gate bias is 0, the channel is already created, so the current will flow before we add the gate bias. So as you can see, before the VG gets 0, the current already flows, right? So if you want to turn it off, we have to put the VT for negative, so we can draw the transfer characteristics graphs like this. And for the p-type enhancement mode and depletion mode's transfer characteristics, we can think about with the opposite ways. So it's a p-type, so we have to put the threshold voltage for negative, and the drain current will be negative also because it's a p-type, and so the current will flow opposite direction with the n-type. So we can draw a p-type enhancement mode transfer characteristics like this with the opposite way with the n-type. And the same way, we can draw a p-type depletion transfer characteristics with the positive threshold voltage and the negative drain currents. So we can draw transfer characteristics like this. And for today, we talked about the terms of the MOSFET, and I hope I explained well, but I don't think so. But anyways, this is the end, and thanks for listening, and see you next time. Bye.